We begin by looking at our wireless configuration. That's fine. WLAN 0, so arrow dump NG, WLAN 0. We're looking for our access point test2 again, and so we see it there. So we stop arrow dump NG. We see that test2 is on channel 11. We also want to get its BSS ID. We can copy this. Another piece of information that we'd like to know is whether there are any clients that are aware of test2 and that might be at least probing for test2, perhaps even associated with it. So we see that we have the station here, 9094, that is probing for test2. We try again with channel 11 to reduce the clutter. So test2, okay. Now, in fact, we see that this BSS ID, this is for test2. So the station 1994 E4 072171 got associated with test2. If we're just going to do an arrow dump now, just to try to get the traffic from test2, we can do this minus BSS ID test2 to filter out the other access points, and then write that to test2. Oh yeah, in this case we gave it an ESS ID, so okay, put it this way. And it's going to take us a while to get a handshake because the client has connected and it is not necessarily going to be de-authenticating anytime soon. So if we are not so patient and don't want to keep waiting around, and we don't mind doing something a bit active rather than being completely passive, what we can do is a de-authentication attack to de-authenticate this client, and usually what will happen is that it will then immediately try to connect again with test2, and that will allow us to capture the handshake. So we do that using air replay ng minus deauth 1 minus a, the BSS ID, minus c. Now we have to get the client MAC address here. Sometimes stopping arrow dump ng can be helpful because it will refresh the information when it restarts. Yeah, so it was this one, 1994. That's the one of interest. So we're going to try to get 9094 E4 072171 to be de-authenticated, and then it will try to re-authenticate, and in that process then we can capture the handshake. This is different from our first demo of WPA PSK and WPA2 PSK cracking, where we went to manually disconnect the client from the network and then try to reconnect it again, because we don't always have, and usually we don't have, that kind of control over most of these clients that are around. Alright, so let's proceed. Alright, so it de-authenticated the station. Well, we still didn't get the handshake. Why did we fail in our de-authentication attempt? We booted off the client from the access point when it was associated and authenticated, and it did not come back to try to re-authenticate and associate with the client. Therefore, we couldn't capture the four-way handshake. We couldn't induce the four-way handshake to occur because the client wasn't cooperating. It wasn't coming back. The reason is not because of the Wi-Fi specification specifically. It's more a matter of client behavior. That's just the way that it's implemented. And this client is on a Windows machine. So in the Windows operating system, that was a Windows XP machine, by the way, you can specify the preferences for the Wi-Fi access points that you will automatically connect with. And in this case, it was having the access point test2 as the top priority, but then there were several other priorities after that, and unfortunately we were within range of one of the other access points. So what happened when we booted off our client from test2, instead of trying to reconnect to test2, it just went down the list and connected to the next access point in the list. Okay, so you have to be aware of the behavior of the software. Sometimes it might be doing these kinds of things. So what I have done now is to remove that other access point from the list. So it will then not be able to find some other alternative and then try and reconnect to test2 again. So then now we can retry our deauth attack. And let's just take a look to see where test2 is, and then we will try that again. So test2, let's see, do we see it somewhere? Yep, test2 is there. It's on channel 11. Okay. So channel 11 to filter out the other channels. And we wait for the client to reconnect. So we're looking for 90, 94 something. There we see it. It attempted and it got the handshake, but this is the initial attempt. We want to try the deauth attack, so we pretend that we didn't capture this handshake. Anyway, we didn't write this to a file, so it's kind of not helpful for us. So now we're ready. We will write to a file. And yes, so of course our client is associated with our test2, but we don't have the handshake. So now let's try the deauth again. Replay, yes, replay ng deauth. So let's proceed, and when we do that, then you can take a look up here to see if it gets a handshake. So, okay, so we did that, and let's see. Okay, yes, successful. Compare this with what we had done earlier, where we manually went to the client. That was not a realistic thing to be doing. In practice, what we just did is what you want to be doing, because you wouldn't have access to the client machine, which will be some Windows laptop or whatever, and you will be doing something like this to make it disconnect momentarily, and then it reconnects. The human user might not even realize that it had been disconnected, because it would automatically then reconnect. Of course, they might reconnect to a different access point if there was that list and it could find one of the other access points. That is an operating system specific behavior. But anyway, in this case, we have shown how then we can induce the client and the access point to redo a handshake and allow us to capture it.